Welcome to this explainer. Okay, listen up, because today we are treating your Cambridge computer science exams like what they truly are, an Olympic decathlon. Think about it. You got 10 different disciplines, 10 distinct challenges, and you have to master every single type of question they throw at you to take home the gold. Whether you're taking syllabus 0417, 0478, 0983, 0984, 2210, or specifically tackling 9618, you already know the absolute basics of logic gates. But today is different. We are going to completely transform your understanding of the AND gate. We're taking it from simple, boring rote memorization and turning it into a devastatingly effective, top-scoring exam strategy. We are going to look exactly at what the examiners are desperately searching for in your answers and exactly how you can deliver it to them every single time. Right off the bat, let's dive into this by confronting a major frustration. I see it all the time. Why are we losing marks on a seemingly basic topic like the AND gate? You know what an AND gate is. You know what it does. Yet somehow when the results come out, the maximum marks on those exam questions just slip away. Why is that? Well, let me introduce you to two types of students I see every year. Let's call them Alex and Sam. Now, Alex overloads their exam paper with raw computer science facts. They write paragraphs of definitions, but there is absolutely zero analysis. Then you have Sam. Sam is always rushing against the clock, completely missing the specific command word requirements in the prompt, and just slapping down an answer without context. I've seen both of their flawed answers covered in red pen marks from the examiners. The harsh reality is that too often we focus entirely on raw facts, just like Alex, or we rush past the context, just like Sam, instead of applying the analytical reasoning that the assessment actually demands. To fix this, we are going to systematically unpack the 5 critical areas you need to master. We'll cover the logic gate trap, core principles, the procedural framework, examiner warnings, and finally, your strategies for top marks. Section 1. The logic gate trap, analytical depth versus superficial breadth. Okay, so here's the crucial point you absolutely must understand. Simply memorizing what a gate does isn't enough anymore. It just isn't. The assessment framework for this syllabus, and really any Cambridge computer science syllabus, prioritizes analytical depth way over superficial breadth. The syllabus itself explicitly emphasizes that top-performing students exhibit connected conceptual understanding. What does that mean for you on exam day? It means rote learning, just repeating what a textbook says, is going to completely fail you the moment you are presented with a completely unfamiliar, complex scenario. Examiners are actively testing your ability to decode command words. To beat this trap, top students use the Peel framework: point, evidence, explanation, link. It's an incredible structure. You make your point about the logic gate, provide the binary evidence, explain the mechanism, and link it right back to the specific real-world scenario in the question. This is how you prove analytical depth. Section 2. AND gate core principles: symbol, function, and truth table. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's get back into it. It is absolutely critical to start by explicitly defining our terms. In fact, if you read the principal examiner reports, they consistently note that top candidates never skip this step. An AND gate implements logical conjunction. It's an unbelievably strict condition. It outputs a true, represented as a 1, only if all of its inputs are true. Not some of them, all of them. This is the absolute core principle you need to establish before you start trying to build complex answers. Now, look at how a truth table brilliantly illustrates those exact logic states for inputs A and B and output X. Notice how the output is 0 for almost every single combination, except for that magical moment when both A and B are 1. This right here is where we see a massive transformation in how students answer. If you recall our student Alex would try to write a massive, confusing paragraph trying to explain these states. But top candidates know better. Truth tables are the absolute most efficient way to extract and represent binary data clearly for the examiner. They cut through the noise and prove, instantly, that you understand these causal relationships perfectly. You are showing the examiner the data, not just telling them a story about it. Now, I know under exam pressure, things can go blank. So to lock this in, I want you to use a visual story method. It's an incredible memory hack that completely bypasses panic. Imagine the physical D shape of the standard AND gate symbol. Got it in your head? Now picture that shape as a massive, very strict bouncer standing outside a club. This bouncer demands 2 things before you can get past the velvet rope: an ID card, let's call that input A, and a ticket. Let's call that input B. He is only going to let you in, giving you that successful output of 1, if you have your ID and your ticket. If you're missing the ID, or if you're missing the ticket, or if you show up with nothing at all, the output is a flat 0. You are not getting in. Visualizing that specific, strict relationship makes it literally impossible to forget when you're sitting in that exam hall staring at a blank page.
Section 3. The procedural framework, earning the method marks.
Let's see how this builds what I call the computer science success blueprint, a guaranteed methodology for complex problems. When tackling an examination question, you must follow this standardized sequence. Think of it as a checklist you mentally tick off. Step 1. Extract the relevant data from the binary representations. Don't just skim it, pull out the exact numbers you need. Step 2. Select your analytical framework. Are you using a truth table, a logic circuit diagram? Decide before you write. Step 3, execute your analysis using clear working and perfect notation. Step 4, verify your results. This is where you double-check your logic. And finally, Step 5, present your answer using the correct terminology. I know it sounds rigorous, but it forces you to slow down, stopping you from making those rushed errors like our student Sam, and guides you to execute your analysis perfectly.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, this brings us to a vital insight into the examiner's mind, the method mark strategy. Listen to me closely on this one. Examiners actively want to reward your logical, systematic sequence. Even if your final calculation goes slightly awry at the very end, if you have demonstrated the correct procedural framework on the page, you can still pick up crucial method marks. The process is literally just as important as the destination. Show your working, show your logic, and you safeguard your grade. Section 4. Top examiner warnings, pitfalls to avoid.
Let's turn this into an interactive workshop right now. These bullet points are the top mistakes holding students back year after year. Let's do a quick challenge, a data scan. If I show you a complex logic circuit, you need to extract the core trend immediately. The classic trap students fall into here is using the wrong algorithm for the context provided. Another massive failure point, and let's call this challenge 2, find the flaw, is forgetting to verify boundary conditions in edge cases. If you see a sample paragraph where a student says the output is always 1 when inputs are active, you have to spot the flaw. What if it's an AND gate? Furthermore, examiners aggressively note that candidates frequently provide generic answers that completely ignore the specific real-world context of the question. You can't just talk about logic gates in a vacuum if the question is about a factory's automated safety system. And lastly, a major alert. Candidates consistently confuse key terminology. Don't be that candidate.
Section 5. Strategies for top marks, evaluative thinking.
Notice how the top-scoring approach doesn't just state facts. Think of this as our third challenge, speed writing. If you had a 30-second timer to write one perfect Peel paragraph, what would it look like? The standard candidate, our friend Alex, simply lists what an AND gate is. They just brain dump isolated facts. But higher-order assessment objectives demand so much more. A top-scoring answer actually demonstrates evaluative thinking. It considers multiple solutions. It analyzes the trade-offs of using an AND gate versus an OR gate in a specific circuit. It identifies both similarities and differences using comparative connectives like however, whereas, and in contrast. And crucially, the top scorer justifies every single decision they make with hard, undeniable evidence from the scenario. That is how you turn those red pen marks into green check marks. Remember that examiner warning about confusing terminology? Well, this right here is your ultimate shield against it. Always, always explicitly define your terms before you use them in an extended response. This simple step acts as an anchor for your whole essay. It proves to the examiner immediately that your reasoning is based on established, solid principles, setting a structured foundation for the rest of your analytical answer. To really lock this in, you need to follow 3 rules that guarantee top marks. Number 1, command word decoding. Know exactly what evaluate or describe means. Number 2, Peel framework application. Always structure your thoughts. And number 3, a time management matrix. Never spend 20 minutes on a 4-mark question. We return to this core idea from the syllabus because it is just that incredibly important. Principal examiner reports continually highlight that candidates who reference cross-topic connections achieve significantly higher marks. You cannot view the AND gate in total isolation. You have to think about how its strict logic integrates with your programming skills, your algorithm design, or even hardware limitations. Cross-topic integration is your absolute ultimate weapon in computer science. And speaking of ultimate weapons, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at aceexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @theaceexams_IGCSE and click that bell. Don't let another exam pass you by. As we wrap up this explainer, I really want you to take a second and reflect on your own approach. Be honest with yourself. Are you just memorizing those truth tables, crossing your fingers and hoping for a simple recall question? Or are you going to adapt your revision strategy today to prioritize analytical depth, clear procedures, and high-level evaluative thinking? The marks are out there, sitting on the table, just waiting for the candidates who decide to think like an examiner. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Thank you for joining me, and I challenge you to apply this entire methodology to your very next past paper. You've got this.